Welcome to aminacademy.com. In electrical engineering, let us discuss about capacitors are in series and parallel. Capacitors in series and parallel may be connected in series or in parallel to obtain a resultant value which may be either in sum of the individual values in parallel or a values less than that of the smallest capacitance in the series. That means in parallel, sum of the equivalent capacitor is the sum of individual capacitors, in and in parallel, that is equivalent capacitor is smallest value, that is less than the smallest value of the individual capacitor. Now we will discuss about in series capacitance in series. A circuit consisting of number of capacitors in series is similar in some respect to one containing several resistors in series, like this. In a series capacitive circuit, the same displacement current flow through each part of the circuit and applied voltage will be divided across the individual capacitors. Look at here. In series, we know that voltage is distributed and current is same throughout each capacitors. Yeah, that means total voltage V equal to V1 plus V2 plus V3 here. Now, the sum of the capacitor voltage must be the source voltage, that is by V equal to V1 plus V2 plus V3. The charge on all capacitors must be the same. Charge is same in series capacitors since the capacitors are connected in series, and any charge movement in one part of the circuit must take place in all part of the series circuit. That is, we know that C equal to Q over V. Therefore, from that V equal to Q over total capacitor CT. Now, already the voltage is distributed. Therefore, V1 equal to Q over C1. Q is common, and V2 equal to Q over C2, and V3 is Q over C3. Now, addition of the voltages, that is Q over CT, that is voltage, main voltage is Q charge over total capacitance, which is equal to Q over C1 and Q over C2 plus Q over C3. Take out Q common, and that is, look at here, Q over CT equal Q, take out common, 1 over C1 plus 1 over C2 plus 1 over C3, then Q and Q cut, so which gives 1 over CT. 1 over reciprocal of the total capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Now taking the reciprocal, that is, we can get CT, the total capacitance, is equal to 1 over C1 plus 1 over C2 plus 1 over C3 up to 1 over Cn if more capacitors are connected in series. This is the equivalent capacitor CT. Now, if it is only two capacitors, CT is C1 into C2 over C1 plus C2, multiplication of two capacitance and divided by the addition of two capacitors. Now, look at this one example. Determine the total capacitance of series circuit containing three capacitors whose values are 10 nanofarad, 0.25 microfarad and 50 nanofarad. Look at here. Look, this one. We know that in series circuit, 1 over total capacitance CT equal 1 over C1 plus 1 over C2 plus 1 over C3, which is equal 1 over 10. First is 10 nanofarad, 10 into 10 power minus 9 plus 1 over, second is 0.25 microfarad, 0.25 into 10 over minus 6, that's micro. 1 over C3 is nano. 50 into 10 power minus 9. Now look at here. 1 over 10 into 10 power minus 9 is equal to 10 power 9 over 10 plus 1 over 25 is here 10 power 6.25 plus 10 power 9 over 50. Now further here, which is 1 into 10 power 8, because 10 power 9 over 10. 10 power 9 over 10 is 10 power 8, and 1 over 0.25 is 4 into 10 power 6. Then 10 power 9 means, suppose 10 power 9, this is equal 20, at least we can put it to. That is 2 into 10 power 7. 2 into 10 power 7. So take out common is 10 power 6. Here 10 power 6 is 100 because 10 power 2 balance. Then 4 plus 20, which is equal 124 into 10 power 6. 10 power 6, here you can see this was farad. Next question, capacitance in parallel. When capacitors are connected in parallel, that is, look at here parallel circuit connection. One plate of each capacitor is connected directly to one terminal of the source, while the other plate of each capacitor is connected to the other terminal of the source. In the figure below, all the negative plates of the capacitors are connected together and all the positive plates are connected together. The total equivalent capacitor CT therefore appears as a capacitance with the plate area equal to the sum of the all individual plate areas. That means sum of all capacitance in parallel. That is, equivalent capacitor is sum of all individual capacitors. Therefore, next is here, therefore CT equal 1 over 124 into 10 power minus 6. Now we can calculate these values here. One divided by 124 is equal 0.00806 into 10 power 6 is equal 4, which is equal Therefore 8064 8064, this is minus here, so we have this was 00806 microfarad. You look at here on what time, 10 power 9 over this. So this much microfarad. Next question, we talked about capacitors are in parallel. So now capacitors in parallel. The total capacitance can be calculated mathematically by applying the equation C equal to Q over V to each capacitor and the total capacitance. In parallel, voltage is not distributed, voltage is common and charge is distributed. Therefore, CT, total capacitance, is equal to Q total, that is total charge over V. Then C1 equal to Q1 over V, because Q is distributed, V is not distributed. C2 equal to Q2 over V, C3 equal to Q3 over V. The total charge is addition of all charges. That means Qt equal to Q1 plus Q2 plus Q3. Now, charge Q equal to cross multiplication at CTB equal to Qt. And C1V plus C2V plus C3V. Here, take out V common. C1, C2, C3. Then V cut. Therefore, we have CT equal to C1 plus C2 plus C3 up to Cn. That is, up to n capacitors are in parallel, then CT equal to here. Here 3 capacitors are parallel, so we have CT equal to C1 plus C2 plus C3 in this figure. Now we can understand this concept in example. Determine the total capacitance of a parallel capacitive circuit containing 3 capacitors whose values are here. This is nano. Look at CT. Total capacitance is C1, C2, C3. So C1 is 30 nanofarad plus 2 microfarad plus 0.25 microfarad. Nanofarad is 30 into 10 power minus 9 farad plus 2 into 10 power minus 6, that is microfarad. We are converting farad to micro to farad, then plus 0.25 into 10 power minus 6 farad, all in farads. Now further we have to convert this as 10 power 6, that means 0.03 into 10 power minus 6, because 3 place move and we converted this also 10 power minus 6 plus 2 into 10 power minus 6 plus 0.25 into 10 power minus 6. Then 10 power minus 6 is taken out common, 0.03 plus 2 plus 0.25, which is equal, addition is 5 plus 3 is 8 and 2 plus 0 is 2 and whole is 2 into 10 power minus 6 farad, which is equal to 2.28 microfarad. So far we discussed about setup of capacitor in series and parallel, and we found total capacitance in that circuit. Also we did some example problem. We have done. Please subscribe our YouTube channel.